Hi guys, Dr. Kruse. This is an algebra video. We're going to talk about minimums, maximums, and we're going to talk about how average rate of change or slope changes on a curve. All right. I'm going to start my drawing right here, just anywhere about halfway up the paper on a piece of graph paper. First thing I'm going to start with is I'm going to do a slope of 5. A slope of 5 means it goes up 5 steps, 1, 2, 3, 4, 5, and 1 step over. That's a slope of 5. We're going to call it average rate of change instead of slope, but it means the same thing, all right? Let's just think of it as the same thing. I'm going to change my slope. I'm going to change my slope from 5 to 4. So from this point, I'm going to go 4 steps up, 1, 2, 3, 4, and 1 step over. That's a slope of 4, which we're going to call it average rate of change. And let's continue changing the slope. I want you guys to watch what happens as I change the slope. If I change the slope to 3, 1, 2, 3, and 1 over, and then 2, up 2 and 1 over, and then 1, and then finally 0, I don't go up, I just go over. Watch what has happened to my line, all right? My line, which started out straight, has started kind of leaning over to the right. It started curving. So when you change the slope, you kind of curve the line. What started out as a line turns into a curve. All right? Note that at the top, our slope is 0. That's a horizontal line, all right? The slope at the top is 0. And at the top, this top of the hill, top of the mountain, the peak, we call that the maximum. And we're going to talk a little bit in a minute about maximum value. All right, so at the maximum, at the peak, note that the slope is 0. Now from there, we're going to start going downhill. And when you go downhill with slope, your slope is negative. So I want to kind of mirror what I did right here. I'm going to create a mirror image over here. And let's start slowly. Let's start with a slope of -1. All right, that means go down 1 and right 1. And it's negative because we're going downward. These guys were all positive because we went up. Whenever you have a slope that goes up, all right, I'm going to do it with my finger. Slope goes up, slope is horizontal, slope is down. So down, that wasn't very good. There's upward slope, there's a horizontal slope of 0, and there's a downward slope. So if your slopes go up, your measurements are going to be positive. And if your slope goes down, your measurements are going to be negative. If your slope is perfectly flat or horizontal, your slope's going to be 0. All right, so let's start heading downhill. Down 1 over 1, that's a slope of -1. Down 2 over 1, that's a slope of -2. 3 down and 1 over, -3. 4 down and 1 over, -4, and 5 down and 1 over, -5. Notice that the line is getting steeper, all right? Steeper, in this instance, when we're talking about slope and average rate of change, steeper means faster. I mean, think about a speedometer. 1 mile an hour, 2 miles an hour, 3 miles an hour, 4 miles an hour, 5 miles an hour. Your speedometer is increasing. We're speeding up, okay? So uphill slopes, uphill average rate of changes are positive. Downhill slopes, or downward average rate of changes are negative. And at the top, at the peak, your slope or your average rate of change is 0, and we call that a maximum. Now just to name the parts of this curve, well, first of all, the whole upside down U shape here is called concave down. Concave down. If it looks like an upside down U, I like to think that it looks like a frown, all right? It looks like somebody frowning. So concave down looks like a frown. Now the two parts of the concave down are where it's going up and where it's going down. There's two parts there. If it's going up, we say it's increasing. And if it's going down, we say it's decreasing. We also say what direction, we also say what's happening to our slope, what's happening to our rate of change. All right, so think of rate of change as speed. Think of it more specifically as your speedometer. If your speedometer is going from 5 to 4 to 3 to 2 to 1, that means you're slowing down. Slowing down means you're decreasing. So your rate of speed is decreasing. Your speedometer is decreasing. Your average rate of change is decreasing. So for this section right here, we say whether it's going up or down, and then we kind of tell what the speedometer is doing. So this is going up, and it's slowing down. So we say it's increasing, but at a decreasing rate. It's going upwards, but it's slowing down. For this over here, it's going downwards, so we use the decreasing. We use the word decreasing. And look at your speedometer. It's speeding up, 3 miles an hour, 4 miles an hour, 5 miles an hour. It's kind of like you're rolling downhill and picking up speed. You're speeding up. So it's going downhill and speeding up. It's decreasing at an increasing rate. My speed, my velocity, it's increasing. All right. Now we're fixing to draw the U shape, which is concave up. And I'm going to start right here at this point here. See our beginning dot? And if I slide over, this is where we ended up. This is called an inflection point. Let's get back to that in a minute. But this is where it changes from concave down to concave up. We say it changes concavity. Okay, I said we're going to get back to it in a minute. Let's just do it right now. So right here at this point, it changes from concave down to concave up. It changes the shape of the concave. It changes concavity. This is also where the graph is the steepest. That's kind of where we're going the fastest, all right? Notice it wasn't very steep right here. That's not very scary. But then it gets steeper and steeper. It's getting scarier and scarier. And then right here, you're going 5 miles an hour downhill. All right, this is top speed right here where it changes from concave down to concave up. That's where your top speed is. That's where the graph is the steepest. That's where you would be going the fastest if that was really a speedometer. All right, that's your highest average rate of change right there at the inflection point. That's an important point. Okay, so let's kind of draw the concave up portion of this curve. So, just continuing with that 5 miles an hour downhill. 1, 2, 3, 4, 5 steps down and 1 step over. That's a slope of -5. We're going to call it an average rate of change of -5. 4 steps down and 1 step over. That's -4. 3 steps down and 1 step over. Average rate of change of -3. 2 steps down and 1 step over. 1 step down and 1 step over. And finally at the bottom, which we call a minimum, the slope is again 0. So at the minimum and the maximum, the slope is 0. Okay. All right, we're heading back uphill. Now that we're uphill slopes are positive. So we start out at 1 mile an hour, 2 miles an hour, 3 miles an hour. We're picking up speed. So up 1 over 1, that's 1 mile an hour, or a slope of 1, or an average rate of change of 1. 2 steps up, 1 step over, that's an average rate of change of 2. 3 steps up, 1 step over, average rate of change of 3. And 4 steps up, 1 step over, 5 steps up, 1 step over, slopes of 4 and 5, average rate of change of 4 and 5. Let's label it from the inflection point to the minimum. We're going downhill, and notice that our rates are slowing down. So we are decreasing, that's downhill, at a decreasing rate. Our rate of speed is decreasing. Our average rate of change is decreasing. Just think of it as your speedometer slowing down. All right, we turn the corner here at the minimum. We head back uphill. That's increasing. And look at your speedometer. It's speeding up, so our rate is increasing. So we are increasing at an increasing rate of speed, or an increasing rate of change. Okay, now that we've drawn the picture, let's talk about the different parts of the curve and their names and what we can calculate. First of all, just a little reminder that f of x is the same thing as y. We used to write it this way. We used to write y equals, and then some function here, some job that we wanted to do. Well, now instead of y, we're going to call it f of x. F is just the name of the function. All right, we could call it g or h or l or m or p or n, whatever. Just if you have a story, you're going to name the function with this letter right here. And this is the number you're going to put in for x. And this is just the job you want to do. This is the function right here. So we call that function notation. But what I want you to remember is that f of x and y are the same thing. Think of them the same way in your head. So if I ask you what's the value of f of 4, I just want to know how does the function turn out if I put in 4 for x. So it looks like here. Here's my function. I'm going to replace x with 4. So I'm going to say the function in terms of 4, or f of 4, is, and I just replace x with 4 and I work it out. This is performing the function, and out comes 14. So 4 is my input, 14 is my output. It's going to look like an ordered pair, 4, 14. 4 went in, 14 came out. We used to say x is 4 and y is 14. That's how we used to say it. Now we say x is 4 and f of x is 14. It means the same thing. F of x and y are the same thing. So get used to, changing your thought patterns from x, y to x, f of x, because y and f of x are the same thing. All right, looking at, a concave down curve here. And ignore the dashed lines just for a second, because the dashed lines are kind of what you're thinking in your head. So if I just give you this curve here that's concave down, and I ask you, okay, what's the smallest value of x for which your curve is 3 steps high? How do I know they're talking about 3 steps high? Because this is y, and y tells me how high. They're telling me y is 3. Well, let's go over to our y-axis. That goes up and down. If I go 3 steps up, my question is, when is my curve this high? So I just draw a dashed line over and I say, well, it's right there. There it's 3 steps high. And if I keep going, I hit it again. It's 3 steps high again. So drawing this dashed line tells me when the curve is 3 steps high. Just think of like a baseball throwing up in the air. All right, and you throw the baseball up and it reaches a certain height and it goes a little bit higher, and then it comes down and it hits that same height on the way down. So there's going to be 2 different times that it is 3 steps high. All right, there's going to be 2 different times that it's 3 steps off the ground. On its way up, it's going to be 3 steps off the ground, and on its way down, it's going to be 3 steps off the ground. So as time goes by, your x-axis is your time axis. As time goes by, maybe these are seconds. 1.2 seconds later, after you threw it, it was, let's say that stands for 30 feet up in the air. And then 2.4 seconds after you threw it, it was coming back down, and it's again 30 feet in the air. And eventually it lands back on the ground. All right? So if they ask you, what's the smallest value of x, they're asking for x when y is 3. Well, y is 3 here and here. Just drop down and see what your x values are. So y was 3 when x is 1.2. Looks like this. Y was 3 when x was 1.2. Here's another one. Y was 3 units high when x was 2.4. Y was 3 units high when x was 2.4. X, y, x, y. There's 2 different x's that produced a y of 3. They're asking for the smallest x. Well, this is 1.2, that's 2.4. This is the smallest x. So if they ask you for the smallest x for which y is 3, you would want the 1.2. If they ask you for the largest x for which y is 3, then you would want the 2.4. Okay, what if we're talking about just simply the maximum? Maybe I don't want to know, when it was these 2 different y values. Maybe I just want to know about the top, the maximum, the high point. All right, I kind of like to tell myself a roller coaster story, and maybe this is time going by. This is 1 minute, 2 minutes, 3 minutes, 4 minutes, and as time goes by, your roller coaster gets higher and higher and higher. Maybe this is number of stories off the ground. You're 1 story above the ground, 2 stories above the ground, and so on. So as the minutes go by, your roller coaster gets higher. It's 1 story off the ground, 2 stories off the ground, 3 stories off the ground, and finally at the high point, maybe it's 4 stories off the ground, and then after that, it gets lower. All right? So as time goes by, it rises and then falls. Well, there's lots of questions about the high point in math and statistics. That maximum. We ask lots of questions about the maximum. So this maximum occurred at 2, 4, when the x was 2 and the y was 4. And these both mean 2 separate things. They're 2 different questions. Remember, this is time. As time goes by, this 2 tells you when the maximum happened. Like if your friend asked you, hey, when did you get to the top? You'd say, oh, that was about 2 minutes into the ride. So when did you get to the top? Did you get to the max? At 2. The x value is going to tell you when. Sometimes they use the word where, but it means the same thing. The x value is time. At what time did this happen? Now the y value is going to tell you how high. I always remember that y is how high, kind of rhymes. So the y value, the highest y value that I have is 4. That's like your friend asking, well, how high did you get? Well, if you follow the roller coaster up, here it was 1 story above the ground, here it was 2 stories, here it was 3 stories, and the highest that it got was 4 stories above the ground. So this tells you how high. And the way they're going to ask you to say, what was the maximum value? What was the highest that you got? How high did it go? So these two numbers answer two different questions. The x answers when something happened, and the y answers how high or even how low that happened. Let's switch the curve and make it a minimum. Same question, when did the minimum happen? Well, after 3 minutes, I hit a low point of 1 story above the ground. My roller coaster is getting lower, then it's 3 stories, 2 stories, 1 story above the ground, and then it went back up to 2 stories, 3 stories, and started climbing again. So this is the low point of my roller coaster. So where or when did it hit the lowest point? Right here. We call that the minimum, the lowest point. The x number tells you when that happened after 3 minutes. 1, 2, 3 minutes went by. I was at the lowest point on the roller coaster. Well, how low were you? Well, I was 4 stories in the air, 3 stories above the ground, 2 stories above the ground, 1 story above the ground, but that's the lowest I got. So 1 story above the ground was the lowest that I got. So the 3 tells me when I hit the minimum, and the 1 tells me how low the minimum was. And finally, I just want to help you answer when a graph is increasing and when it is decreasing. Remember, sometimes they say when, sometimes they say where, but they're asking for the x values. So when is the graph increasing, or I could say where is the graph decreasing? All right, looking at this graph here, now notice that as time goes by, maybe after 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, as time goes by, the graph goes up and then it goes down. All right? So if I'm talking about the graph increasing, remember that's uphill? Well, I'm going to point to it. It's going uphill from here to here. These are the uphill parts of the curve. Now, if I want to answer when that happened, I'm going to drop straight down to my x numbers. The graph is uphill from an x of 1 to an x of 3 for all of those numbers in between. At 1.2, 1.7, 2.1, 2.9, 3, all of those numbers from 1 to 3, if you look straight up, the graph is going uphill. So from x equals 1 to x equals 3. The mathematical way to write it is 1 is less than any of those numbers, which are also less than 3. We're talking about all the numbers in between. For example, 1.5. Well, 1 is less than 1.5, and 1.5 is also less than 3. It's between 1 and 3. How about 2.6? 1 is less than 2.6, and 2.6 is less than 3. Okay, any number that fits in between 1 and 3 will tell you when the graph is increasing. So an easy way to remember this is any number between 1 and 3. All right, so for any of those numbers from 1 to 3, for any of those numbers between 1 and 3, the graph is going uphill. Now, when or where is it going downhill? When or where is the graph decreasing? From here to here. Drop straight down. Here's where it starts decreasing at x equals 3, and it stops decreasing right there at x equals 5. So from 3 to 5, the graph is going downhill. You have to tell when it's going downhill. From 3 minutes or 3 hours to 5 hours, it was going downhill. All right? So x is any number between 3 and 5. For any number between 3 and 5, the graph is decreasing or going downhill. Okay, that's all I got, guys.